So here is our second and final example of how to graph an exponential. So again, we're going to start by identifying the base and figure out our end behavior, our general shape. Okay. After that, we're going to write down our horizontal asymptote, find our y-intercept, and then find any additional points that we may need to get the right bend. Okay, so first and foremost, I notice that the exponent, negative 2x, there's a negative 2 in front of the x, so we're going to do a rewrite again. So this is really negative 4 times 2/3 to the negative 2, and then we're going to raise that to the x power, and then we have a plus 5. So I need to figure out what 2/3 to the negative 2 power is. So that is the same as the reciprocal of 2/3, 3/2. We're going to raise that to the positive 2 power, and then raise this whole thing to the x power, plus 5. Okay, so that's going to come out to negative 4 times 3 squared is 9, 2 squared is 4, to the x power, plus 5. Okay, so our base is 9/4, which, yes, it's a fraction, but it's a fraction that's bigger than 1, so this is going to be a growth model. Okay, and then the coefficient out in front, the a value is negative 4, so that means we have a negative growth model. So a negative growth model looks like this. Starts flat and then becomes steep going down. So our graph is going to look like that. Our horizontal asymptote is at what y equals whatever our vertical shift is at the end, so y equals positive 5. So we have a horizontal asymptote at y equals 5. Okay, so I'm going to go ahead and draw on my horizontal asymptote at y equals 5. So 1, 2, 3, 4, that's all the way up at the top. And we know we're going to be below that based off of our basic shape right here. Okay, so we're going to be below that HA this entire time. All right, let's talk about the y-intercept. So what do we get when we plug in x equals 0? And again, we can go from the original function or the rewritten function. This time I'm going to work from the rewritten function. Okay, so I'm going to get y equals negative 4 times 9/4 to the 0 power plus 5. Any number to the 0 power is really just a 1. So I have y equals negative 4 plus 5, which is y equals 1. So the y-intercept this time is 0, 1, which will fit on our graph very nicely. So 0, 1 is right there. Okay. Now we need some additional points. Okay, so I'm going to try plugging in just x equals 1, see what I get. And I'm also going to try plugging in, we're going to do negative 1, see what happens over there, okay? But these are not necessarily going to be the prettiest of points. All right, when I plug in x equals 1, if, let's see, I'm working from my rewritten function, so that means, hold on one moment while I clear out my other things. There we go. These are all the numbers that will change on us. So I'm raising 9/4 to the first power. So that's really just 9/4. All right. Those 4s will cancel off. I'll be left with a negative 9 here, and negative 9 plus 5 is negative 4. So I have the point 1, negative 4. So let's add that point to our graph. 1, negative 4. 1, 2, 3, 4. Okay. So if I keep going to the right, it should be getting steeper and steeper. Again, that's based off of our original graph, our parent graph, drawn in black. So now I want to go back, and I'm going to plug in negative 1 and see what I get there. And then we should have enough. Each exponential graph should have a minimum of 2 points, but really you should have 3 to get an accurate shape. Okay, So if I plug in a negative 1, 9/4 to the negative 1 power means do the reciprocal of 9/4 to get 4/9. And uh-oh, now we're going to have to deal with a fraction. We have negative 16 over 9. So I'm going to change that 5 to have a denominator of 9. So let's see. 5 with a denominator of 9 is going to be 45. 45 minus 16 is 29. So this is 29/9. Oh, what a crazy, crazy number. But if you think about that as a mixed number, that is 3 2/9. 3 2/9. So it's 3 and a little bit, all right? So, I'm sorry, that should have been in red, my bad. But this is 3 2/9 here. I'm going to need a little bit more space, I think. 3 2/9. Okay, so if I go ahead and try to plot that point, negative 1 up 1, 2, 3, a little bit above 3, something like that. And now I should be ready to sketch my graph. So if I start over on the left near the HA and then curve down through my points, that is the graph that I want for this particular function. So that's the graph of y equals negative 4 times 2/3 to the negative 2x plus 5.